Okay, first question for today is in how many different committees of 7 members can be formed from 8 Japanese and 4 Korean. Okay, in how many ways different committees of 7 members can be formed from 8 Japanese and 4 Koreans? 4 Koreans. This is our answer. This is our question. Okay, there are altogether 8 Japanese and 4 Korean. We have to form the committee of 7 members in total. The question has not given us the conditions or restrictions whether the definite number of Japanese or definite number of Koreans should be taken. That's not stated by the question, so that is why we can do it by our own. And the formula for combination of n items taken r at a time is given by n factorial over n minus r factorial. This is discussed for several times. Now we will use the same formula for the calculation of this question also. Now, how many different options can we make here for the formation of 7 member committee? We have how many Japanese? We have 8 Japanese,
Japanese,
right?
8.
Similarly, we have 4 Korean. We have 8 Japanese, 4 Korean. In total, we have to make 7 members. We can make 7 members. Now, so there are various options for the formation of this committee. Like for example, we can take 0 Korean, and if we do not take any Korean for the formation of committee, then how many Japanese should we take for the formation of 7 members?
7 Japanese.
Right, 7 Japanese should be taken for the formation of 7 member committee. Similarly, if we take 1 Korean, then how many Japanese can we take?
6.
6. Similarly, if we take 2 Korean, then how many Japanese can we take? 5.
5.
Similarly, if we take 3 Korean, then we can take 4 Japanese, right?
4. Yeah.
Similarly, if we take 4 Korean, then we can take how many Japanese? 3 Japanese for the formation of this committee, is it?
Yeah.
Okay, so these are the various
Yeah.
various options that we can form this 7 member committee. Now, what will be the total number of the ways that we can select 7 Japanese and 0 Korean? What is the total number of the ways that we can select 7 Japanese? How much it will be? From how many Japanese should we select the 7?
Yeah.
What will be the total number of the ways then?
Uh, 7C0.
7C0? No.
How many ways?
In how many ways the 7 Japanese can be selected? We need to select 7 Japanese. In how many ways can it be done?
Yeah.
In total, how many Japanese do we have?
8.
8 Japanese. Now, how many Japanese
There's
should we
a
select?
C7. 8 C7.
Right, 8 C7 ways. Into how many? In how many ways can we select 0 Korean from 4?
Um, times 4 C0.
4 C0, right. Now, in the same way, we have to select
Yep.
6 Japanese from 8. What will be the total number of ways?
8 C6
8
times 4
C6.
C1.
Right, 4 C1. And then this third option,
8 C5.
8 C5,
C2.
4 C2. Next,
8 C4
hmm,
times 4 C3.
okay. Next,
8 C3 times 4 C4.
okay. These are the total number of the ways that we can form the committee of 7 people. Now, what will be the total number of ways then? These all are different options. Either we can go with the option number 1 or 2 or 3 or 4 or 5. These are options for us. So that is why if there are different options, then total number of ways will be the sum of these all options, right? So what we can do is we can add all this 8C3 times 4C0 plus 8C6 times 4C1 plus 8C5 times 4C2 plus plus 8C4 times 4C3 plus 8C3 times 4C4. So this will
This one is
be,
8 C7.
yes, it is 7 now.
Yeah.
8C7 times 4C0 plus 8C6 times 4C1, 8C5 times 4C0, 4C2, 8C4 times 4C3, 8C3 times 4C4. So this is the total number of the ways. I think it can be calculated. Okay, can you solve it?
Yeah, I'll solve it.
Okay, then I'll give you next question.
Mm-hmm.
Do it by yourself. How many ways, in how many ways can a committee of 5 members be selected from 6 men and 5 women consisting consisting of 3 men and 2 women? Okay, this is our question. In how many ways can a committee of 5 members be selected? The total number of the members in the committee is 5. Now, the 5 member committee consists 3 men and 2 women. It is fixed. Number of men and number of women are fixed. Now we need to find in how many ways it can be done. How many committees can be formed? and the committee should consist three men and two women. And three men should be selected out of six men. Two women can be selected out of five women. Now get the answer. How much you'll get? In how many ways can a committee of five members be selected from six men and five women consisting of three men and two women? In how many ways three men can be selected? Two men can be selected in how many ways?
Uh, Two men with three
Three,
women.
three men can be selected in how many ways?
Three men. Six. Six. C3.
Right. And two women can be selected in
5C2.
5C2. Okay, then here you can write three men
Mm-hmm.
and two women can be selected in 6C3 times 5C2 ways. There are not other options here because the question has given us the fixed number of men and a fixed number of women in the committee, so that is why we do not have to think other options. It is fixed already. The five members of the committee is already fixed. That it should contain three men and two women. So that is why three men and two women can be selected in 63 times 5C2 ways. Now how much it will be? 6C3. 6 factorial over 6 minus 3 factorial. 3 factorial times 5 factorial over 5 minus 2 factorial times 2 factorial. 6 4 3 factorial divided by 3 factorial times 3 to 1. 5 4 3 factorial over 3 factorial times 2 into 1. Do you have any confusion on this calculation?
Um, no.
This 6 factorial is expanded up to 3. Okay, here we have forgotten to write 5. Here should be 6, 5, 4 and then 3.
Mm-hmm.
And this 3 and 3 factorial can be cancelled. 3 factorial get cancelled. Now we can reduce it. 3 times 2 is 6. This 2 will also cancel this 2. Now we'll get 5 times 4. And similarly, we can cancel this 4 by 2. 2 times 2 is 4. 5 to the 10. Now if 5 for the 20. 20 times 10 is 200. 20 times
200.
10 is 200. So the total number of ways equals to 200. This is our answer. The total number of the ways that a committee can be formed is 200. This way we can do. If there are some options, then we have to find out the total number of ways uh, of every option. And after finding that, we need to add all those options to find the total number of the ways that the committee can be formed. But if the committee consists exact number of the men and women, then there will not be any other options. So that is why this only one option is there. So we'll calculate this, and that will be our final answer. Any questions on this?
No.
Hmm. Okay, then let's move to question number 3. Question number 3 says, in how many ways can a committee of 4 be selected out of 12 persons so that one particular person is always included, second is always excluded. This type of question was also done the day before yesterday, I think. We had discussed this type of questions. Whenever a particular player is always selected as a captain, and the next case was when a particular person is always ignored, always neglected, is never selected. So that type of question we have discussed. Now this question is similar to that. In how many ways can a committee of 4 be selected out of 12 persons so that one particular person is always included? It will be easier if we draw some simple diagrams here. Like there are altogether how many persons? There are 12 persons,
12,
right?
2, 3,
There
4,
are 12
5,
persons.
6,
Okay.
7, 8, 9, 10, 11.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like this. Now, how many should we select? 4.
Five is
Okay, make
included
4
in it.
spaces like this.
Yeah.
Uh, Now, what does this first question says? One
Also
particular person
included.
is always
Always included.
included. Now, let's include one. Okay, let's include this either. This
Yeah.
first. If this one is included, this will come down, right?
Yeah.
This will come down now. Now, in total, how many are left now?
11.
11.
Yeah.
And how many should we select?
3.
3. Now, we need to select 3 persons out of 11. Now, we have to find the combination of these two numbers now.
Mm.
In the first case, n will be equal to 12 minus 1 equals 11 because 1 has already been selected.
Yeah.
R will be equal to 4 minus 1 again because 1 has already been selected. It has already been included here, so that is why only 3 persons are left to include, left to select. And out of 11, this should be selected. That is why total number of ways equals how much?
And factorial.
NCR
Yeah, NCR.
11
And factorial. Yeah, 11
C3
factorial.
11 C3. Okay,
Uh,
firstly we have to write this 11 C3 and then only we can use its formula.
okay. Yeah.
11 factorial over How much?
11 minus 3 factorial, 3 factorial.
Right. Now, can it be expanded or not?
Yeah.
Hmm. 11,
Total
10,
number of ways.
9, 8. 11 minus 3 is 8, so that is why you can stop here. 11 minus 3 is 8 factorial times. Now, this 3 factorial can also be expanded. 3, 2, 1 like this. Now, this 8 factorial can be cancelled. And similarly, we can reduce these terms as well. Like 3 can be cancelled with this 9. We'll get 3 as quotient. 2 can cancel this 10 and remains 5. We'll get 11, 5 and 3. 11, 5 and 3. It is 165. 5 is 15. 15 times 11 is 165. Okay, in 165 ways, the 4 persons can be selected out of 12 if one person is always selected. If one person is always selected, then we can select 4 persons out of 12 and in 165 ways. Any question in this?
Nope.
Okay, now second case. Let's do selection. In the second case, the question has told us that one person is always excluded. One person is always excluded. If one person is always excluded, then what will happen? Okay,
Yeah,
all together.
then there will be 11 total people.
Okay, and will be 11
N will
left.
be 11.
Okay, and then what will be the value of R?
Will be 4.
It will be 4, right? Because if one person is excluded, then one will be removed from this total list, but
Mm-hmm.
the number of people to be selected will remain same because none has been selected yet, right?
Yeah.
Okay. Now we need to find out the total number of combinations from here. The total number of people is n, that is 12, and number of people that should be selected is 4. It should be 11, not 12. 11. Now what will be the total number of combinations then?
Um,
Combination means number of ways.
11 4.
11
C4.
C4, right. Now total number of the ways will be
11 factorial.
hmm,
11 minus 4 factorial. 4
uh,
factorial.
right. Okay, it can be expanded now. 11 times 10 times 9, 8. Now we can stop at 7 factorial because 11 difference 4 factorial becomes 7 factorial. It can be cancelled, so that is why you can stop here at 7 factorial. And this 4 factorial can also be expanded as 4,
Yeah.
3, 2, and 1. Right?
Yeah.
Now we're going to cancel it. Let's cancel. 7 factorial can be cancelled. 4 times 2 is 8. 4 cancels 8 and the quotient becomes 2. 3 cancels 9 and the quotient becomes 3. 2 cancels this 2. Now the remaining values will be 11 times 10 times 3. Now it will be 11 3s are 33. 33 times 10 is 330. I've got 330 small ways. 330 ways. Have you got the same?
Now the cancel part.
Okay. Any difficulty on this?
Yep, like doing the cancel.
Which one? Which one?
Like when you cancel.
Cancelling?
Yeah.
Okay, this 7 factorial and 7 factorial. Okay, have you understood this? How this 7 factorial
Yeah,
has come?
I already canceled those.
Hmm. This 2 cancelled. Now this 4 cancels this 8. 4 times 2 is 8, right? Okay, let's rub it again.
I did I cancel. Wait.
Okay. This 4 cancels 8. What will be
I
the
get
post?
it. I
It
get
is
it.
it is 2, right?
Yeah, then cancel two.
This 2 cancels this 2.
Ah, yeah.
Now this 3 also cancels this 9, right?
Yeah, yeah.
3 3 is a 9. Now 11 times 10 times 3. 11 times 10
Yeah.
times 3 is 333.
30 ways. Yeah.
330 total number of the ways. Okay, let's do next question. Question number 4. The question has told us that a bag contains 8 red balls, 5 blue balls, 3 black balls. How many selections? How many selections consisting of 10 balls can be made if 5 are red, 4 are blue, and 1 is black? Okay. A bag contains 8 red balls, 5 blue balls, 3 black balls. How many selections consisting of 10 balls can be made if 5 are red, 4 are blue, and 1 is black? I think we can do it by ourselves also. Okay, try it once. Try it once. Total weight equals 8C5 times 5C4 times 3C1. Okay, this is the total number of answer. Okay, let's do question number 5 then.
Yeah.
Question number 5 is a person has got 10 friends of whom 7 are relatives. 7 are relatives. In how many ways can he invite? In how many ways can he invite 5 guests such that Three of them are relatives. A person has got 10 friends, of whom 7 are relatives. In how many ways can he invite 5 guests so that 3 of them are relatives? In this question, total number of friends are
10.
10. Among these 10, 7 are relatives. Then how many are non-relatives?
3.
3 are non-relatives, right? Now, he has to invite 5 guests. And these 5 guests consist 3 relatives, right? 3 of them are relatives
Relatives.
told. How many should be non-relative now?
2
2 should be
non-relative.
non-relative. Now 3 relatives should be selected from how many?
3 out of 7.
7, right? From these 7 relatives, we need to select 3. And 2 non-relatives can be selected from out of 10 friends. Out of 10 friends, 7 are relatives,
3 or no.
uh, 3 are non-relatives. Now,
Mm,
now the person has to invite 5 guests. Now 5 guests means 3 should be
3
relatives,
relatives.
and the question as stated it, 3 of them should be relative. Now if 3 are relative, then 2 should be
Non-relative.
non-relative. Now 3 relatives should be selected out of 7, right?
7, yeah.
And 2 non-relatives should be selected out of
3.
3. Now what will be the total number of the ways then?
For
Number of ways
relatives,
becomes how many? Tell, tell.
7C3
7C3 times
times 3C2.
3C2, right? Right. This is our answer. Okay, this will be our answer. 3 relatives should be selected out of 7, and 2 relatives should be 2 non-relatives should be selected out of 3. And if we add these two values, then only we'll get 5. So that is why this will be the total number of selections, total number of ways.
Yeah.
Okay, let's get this final answer then. Let's get its final answer. Now 7C3 can be written as 7 factorial over 7 minus 4 factorial. Okay, it is 7 minus 3, not 4. 7 minus 3 factorial. 3 factorial. This 3C2, 3 factorial over 3 minus 2 factorial and 2 factorial. Now the 7. 7, 6, 5. Here is 4. 7 minus 3 is 4 factorial, so we can do up to 4. Or if you are confused on this, then you can expand it up to 1 also. Like 5, 4, 3, 2, 1 in this way also. We can expand. It is 4 factorial. It is 3, so 3, 2, 1. Now this factorial, 3 factorial can also be expanded as 3 to 1. 3 minus 2 is 1 factorial. 2 factorial can be expanded as 2 times 1. Now we can cancel this. 2 cancels with this 2. 1 can also be cancelled. 3 cancels with the 3. Now here 1, 1, 2, 2. Now 7, 6, 5, 4 are left. In the denominator there is 4 factorial, so it can be expanded as 4, 3, 2, 1. Now 3 over 1 factorial is 1. Now again it can be cancelled. 2 cancels this 4 and 2 is remained, because 2 times 2 is 4. 2 times 2 is 4. 3 cancels 6 with 3 to the 6, and this 2 cancels 4 becomes 2. 2 cancels this 2. Have you understood this cancellation?
Yeah.
Now we have got 7 only here. 7, and here we have got 3 divided by 1, it will be 3. Altogether it is 21. 21 ways is our answer. 21 ways is the total number of the ways that 5 relatives can be selected out of 10. In this way we can solve. Any difficulty on this?
No. Ways. What about the 5?
Oh, there is 5 also, I left it.
Uh,
Hmm. We should take that also. 5.
7 times 3 times 5.
Hmm. How much it will be?
100.
105?
105. Yeah.
Hmm.
105.
Okay, this is the final answer. Okay, let's do question number 5. Next question.
Okay.
Out of 7 gentlemen and 4 ladies, a committee of a committee of 5 is to be formed. Is to be formed in how many ways? In how many ways can this be done so as to include first is at least one lady, second is at most one lady. Okay, study we the day before yesterday we did this type of question. Out of 7 gentlemen and 4 ladies, a committee of 5 is to be formed. The committee contains 5 people. In how many ways can this be done so as to include at least one lady? The first case. The second case is at most one lady. Okay, let's discuss about the first case.
First, at least one
At least
lady.
one lady. What does this mean by what at least one lady?
One. So if there's at least
There must be
one lady, then there'll be six gentlemen. I mean, no, there should be four gentlemen.
there should be four gentlemen. That is one option. That is one option
Yeah.
because the question has not told us the exact number of lady. It has just told that the committee should contain at least one lady. Means minimum one lady should be there.
Least.
Either that may be
Yeah.
one lady, or there may be two ladies, or there may be three ladies, there may be four ladies also. Means there are several options, right?
Okay.
We have many
Yeah.
options. The committee may contain only one lady. If only one lady is there, then six. Sorry, how many gentlemen should be there? Four gentlemen.
One lady and four
Gentlemen,
gentlemen.
right? If there are two ladies, then how many gentlemen?
Yeah.
Three gentlemen.
Three.
If three ladies, then two gentlemen.
Two.
If four ladies, then one gentleman.
One.
We can go up to four
Okay.
ladies because in total there are four ladies. So these are the several
Yeah.
options that we can have for at least one lady. So we need to calculate the total number of combinations of each options of these all options. Okay, let's calculate it.
7C4 times 4C1.
Seven
7C3 times 4C4
gentlemen, four ladies.
times 4C3. 7C1
Committee should have five.
4.
One lady, four gentlemen, two lady, three gentlemen, three ladies, two gentlemen, four ladies, one gentleman. These are the four options. We have four options here. Okay, what will be the combinations?
7C4 times 4C1.
Okay, 7C4 times 4C1, right. Okay, we can have one value here. Now next, option number two is
7C3 times 4C2.
hmm, you can have another value. Next,
7C2 times 4C3.
okay, last,
7C1 times 4C4.
hmm, okay, these are the four options of formation of committee. Now we can go on one option, means either we can go in the first option, second option, third or fourth. Now in this case,
Mm-hmm.
total number of ways becomes how much? We have to add all
Uh,
these values, right?
yeah, yeah.
Okay, this option number one plus option number two plus option number three plus option number four. After adding it, we'll get one value, and this will be our answer.
Yeah.
Hmm. Now, do you have any problem on this calculation?
No.
If so, then let's discuss on the second case. Second case is there at most one lady is given there. Second case is at most one lady. What does it mean by at most one lady? The
At
committee?
most, max one.
Yes, right, max one. There may be zero lady also.
Yeah, zero.
Then if there is one lady, then how many gentlemen should be there in the committee?
One lady, four.
Four gentlemen, right. And if there is zero lady, then
Five
five
gentlemen.
gentlemen. Are there any other options other than this?
No,
No.
none.
Hmm. Okay, then we have to find the combinations of these two. Option number one is four gentlemen and one lady. Option number two is five gentlemen and zero ladies. Now, in how many ways can this be selected? Four gentlemen and one lady.
Four gentlemen, one lady, 7C4.
7C4. Only this.
Wait, four gentlemen.
It is the selection of four gentlemen. What about one lady?
Okay,
Times.
times
How many ladies are there in total?
4C4, 4C1, 4C1.
Right, 4C1.
Yeah.
In total, there are four ladies. Out of four, one lady should be selected. Okay, you'll get one value there. Similarly, what about this?
Uh, 7C5 times 7C0.
7C0. Okay, now we get another value here. Therefore, total number of options, okay, you can say ways of committee formation equals this value plus this value. There are two options only. So adding the total number of ways of this both option will get the final answer. This is our answer. Any confusion? Any difficulty?
No, no confusion.
Now is this combination clear?
Yeah.
Okay. If so, then I'll give one assignment today also.
Mhm.
This question. Okay, only one question. Five men in a group of 12 graduates. Find the number of ways by which five men can be selected such that at least three of them may be graduates. B number is at least three of them may be non-graduates. Okay.